Welcome to solving three-term equations. This first video is about equations do not involve any brackets. It's just very simple modelling of solutions and where does the answers come from. So we have here an equation 8x plus 6 is equal to 86. Now the left hand side is known as an expression. It's an expression part because there's no equal sign to that side. The right hand side, 86, is the value of the expression when x is actually equal to something specific. Now because we made these equal, this is how an equation is formed. It's when an expression has a particular value and we need to find out what x would be for this equation to work. So the first thing we need to really look at is how was the expression built up. Well, we started off with our number x. It's been multiplied by 8 to give us 8x, and then we've added 6 to finish off the expression 8x plus 6. Now what the equation is telling us is that 8x plus 6 actually equals to 86. Well, that means there must be a cycle somewhere, so in order to reverse the cycle we need to go back the way we came. So if we added 6, then that would mean we would minus 6. So 86 take away 6 gives us 80, which lines up with 8x, and then dividing that by 8 returns us back to the original value of x. So this has x is equal to 10. Now if we was to look at this model a little bit closely, the green bit indicates the bit we actually need. That is the actual answer to the question. Now what would happen if we change the value of 86 in the question to 46 but keep the expression part the same? Well, that would obviously have a change on the bottom line, but the top line actually would remain unchanged. So the value of 86 is now replaced with 46 and the values 80 and 10 are now redundant. So we have to start again, but the model does not change. So if the expression doesn't change, the model doesn't change. 46 take away 6 leaves us with 40, and then dividing 40 by 8 leaves us with our answer, x is equal to 5. So just to practice really in modelling here, you'll have a set of questions beneath this video on this web page, and you'll have a go at actually solving these equations. Well, for now, if we take these two examples that can be taken from that file, 3x plus 1 is 19 and 7x minus 5 is equal to 65, and apply the model, then x means we times it by 3 to give us our 3x, and therefore we added 1 to it to give us our expression of 3x plus 1. We've said that 3x plus 1 is equal to 19, therefore the reverse to go backwards would be to take away 1, and that would give us 18, and then divide by 3, and that gives us our answer of x is equal to 6. Similarly, with the 7x minus 5 equals 65, we start off with our x. We look at how the left hand side has been built. So x times by 7 gives us the 7x, and then take away 5 gives us the 7x minus 5. Notice how the expression on the left hand side tells you virtually exactly what you've got to do. Now 7x minus 5, we've said here, is equal to 65. It has a value. Therefore if we work backwards, we'll work our way back to x. So if we minus 5, that means we add 5. So 65 add 5 gives us 70, and then divide by 7 gives us 10. That would then give us our solution of x is equal to 10. Using the worksheet provided, you've been given a worksheet with models on it, because you don't have to draw it, and use the GeoGebra file that's attached to this web page. Okay, so although this may seem like an extremely long-winded method, it's actually easier to actually explain as to why we use the shorter methods that you generally get taught in class. Now referring back to the last example where 7x minus 5 is 65, in order for that to be true, x had to be 10. Now, the only bits we really need to be bothered with is this. The first yellow box there actually states the question. 7x minus 5 is equal to 65. So all we got to do really is you'd add 5 to both sides. That way you're left with your 7x is equal to 70, and then finally you divide by the 7 to give you x is equal to 10. So the actual bit we're really only interested in is actually where the yellow boxes are now. So understanding why the cycle works should hopefully allow you to access as to how to solve the equation. Have a go at the GeoGebra files below.